Hey guys, welcome back to video 12. In this video, we're going to be covering question 12 for DS 4400s practice exam 2. So like a lot of the other videos, before I actually answer the question, which for this one, this is actually a fairly easy question, I'm going to be talking about the underlying mechanisms or methods that we're using within these questions. So for question 12, this is a rejection sampling question. So we learned in class that rejection sampling, so I'm going to write a definition here. Rejection sampling is the method of sampling distribution P. So a X from P. So this is an observation from P by using X's from Q. So rejection sampling is a way of sampling from one distribution P by using samples from a different distribution Q. And in class, we learned that rejection sampling actually requires, three main inputs, and that is a P, where this is the distribution we want samples from. And more specifically, we actually need the P of X. So this is the PDF function for distribution P. The second thing is we need a Q, where this is a distribution that is easy to sample from. So something I didn't mention earlier, but one of the main use cases of rejection sampling is when P, well, if we want to sample from P, but P may be hard to sample from. So this is hard to sample from. So what we can do is we can use a distribution like Q, which is easy to sample from. And by easy, I mean, these are known distributions, like the Gaussian or the uniform distribution, which, sampling from them is a solved problem. And the final thing we need is K. So K is just a scalar. So if you remember the pseudocode from class, doing one round iteration of rejection sampling simply looks like this. So we sample from Q, so X is a sample from Q. Actually, I'm going to call this U. So U is equal to a sample from Q. So we simply are sampling from Q. And then V is a sample, specifically a sample from a uniform distribution that goes from 0 to K times Q of U. So using this V value, we say if P of U, so remember P is the PDF of the distribution we want to sample from. So if P of U is less than, if P of U is greater than or equal to V, then we accept U. Otherwise, we reject U. So this seems pretty simple, but you might be kind of confused about what's going on. So let's draw a picture. Okay, so let's work through an actual visual example of rejection sampling. So let's say we have a P of X. Sorry, we have a distribution P, and because we have the distribution P, we also have a PDF for P, so that's P of X. And rejection sampling requires three things. So we need a P of X, we also need a Q of X, and a way of sampling, and a sampler of Q of X. So I'm going to say for simplicity that Q of X is just a uniform distribution. So if I draw out Q of X, remember uniform distribution assigns the same probability to all samples. So if we draw out the Q of x, it's probably going to look something like this. It's going to have low probabilities for all samples. So the final thing that we use in rejection sampling is a k-value. And so the purpose of this k-value is to raise this Q of x line so that it's always above P of x. So this is k times Q of x. So now if I copy the steps from rejection sampling, let's walk through a case of one sample. So I'm going to copy this algorithm down here. Okay, so the first step, we generate a sample from Q. And so what we'll get is some value along the x-axis. Remember, Q is a uniform distribution, so every value on the x-axis has the same probability. So let's say we generate a sample U right here. So just to label a few things that we're going to see in our equation, we have k times Q of U, right? That's just going to be this value, right? It's Q of U is going to be some value on a line down here, but k times Q of U scales that value upwards. So this is k times Q of U. And then finally, we also have this point right here, which is just P of U. And this is just the probability assigned to U according to P. So if we look at this second step right here in our equation, what we're doing is we're going to sample along this y-axis for some value along this line. Ooh, I'm going to use a different color. Along this line, right? And what we see in the next part of our equation is, well, if we get a value, so here, if we get a value along this uniform distribution that's kind of like within this range, well, then we'll accept. But if we get a value in this range, and up here, we reject, right? So one intuition that I find super helpful here is, well, we're sampling from Q, right? And then we're sampling from a different distribution. We're sampling again from a uniform distribution for a y value, and this v value, right, which is for the uniform, controls whether or not we accept the sample. And so we have some randomness here, and we can actually model the probability of accepting U. So we say the P, we use P a lot. So the probability of accepting U, is equal to, the size of the space, which is, 0 to k times q of U, which is, simply k times q of U, over, this height, the acceptance height, which is p of U. And since we're uniformly choosing a value along this y-axis, every y value has the same probability. So so we get this equation. Hey guys, so now that we have some background on rejection sampling, let's actually answer the question. So question 12 asks, you're given a uniform distribution between -6 to 6 to perform rejection sampling on a Gaussian distribution with mu 0 and sigma 1. Let k be a multiplier let the k multiplier be 12. In rejection sampling, you generate two samples for each possible sample, v1 and v2, where v1 is the sample and v2 gives you the acceptance rate. From this, you generated three pairs, 0.3, 0.2, or whatever, I don't need to read the pairs. Show the math to explain which samples were generated. I think, yeah, so this is saying which were accepted. And then for me, just to note back to the notation we're using previous, v1, v2 is really just v, u, where this is the sample according to q, and then v is, this is the sample generated uniformly between 0 and k times q of u. Sweet. So with that in mind, I think another important note, so I'm just going to erase some of this, move this over here. Oh, lordy lord. Okay, whatever. Another thing to note is, so one component of this problem, which is hard for you guys since we don't have a calculator, and I think was an oversight of writing this problem, is, well, we don't have P of U, right? We do know, right? So this is a question mark. We do know that P is a uniform distribution with mu 0 and variance 1 squared. However, if you guys remember the Gaussian distribution, calculating a P of some sample is going to be a pain in the butt. So on the real test, we're going to actually give you P of U's. We're not going to ask you to calculate them. So I'm going to write those out real quick. So going through the samples, so we have P of 0.3. This is equal to, I got to go to my notes over here, 0.381. We have P of, 1.2 is equal to 0.194. And then P of -1 is equal to 0.242. Okay. Now with this in mind, I'm going to copy back our pseudocode that we used for looking at running one iteration of, okay, so it's down here, of rejection sampling. So let's move that up. So yeah, so the steps of rejection sampling is, 1, we generate a U value sampled from Q. Remember, that's this first value, so that's 0.3, 1.12, and -1. 2, we generate a V value, which is basically a value along the y-axis, which is a uniform between U0 and K times Q of U. We also have that given to us. That's this V right here. 0.2, 0.5, and 0.1. And so the third step is kind of these components right here. Okay, so let's tackle step 3. So we know P of U. Sorry, let's go through each case. So let's do case 1. So we generated a sample 0.3, right? Here, let's use different colors. 0.3, and we now know the probability of that is 0.3181. And in order for us to accept this sample, we need V to be less than 3.81. Well, so what's V? Well, in this case, V is equal to 0.2, right? And, well, we do know that 381 is greater than or equal to 0.2. So let's accept this. So we accept 0.3. For the second sample, V is equal to 0.5. U is equal to 1.2, and the probability of 1.2 is 0.194. Well, 0.5 is actually greater than, so U is greater than 0.194, which is V. This means we reject 1.2. And then finally, with U3 is equal to -1, with probability 0.242, and V equal to 0.1. Well, 0.1 is less than or equal to 0.242, which means we accept -1. So our final answer, we generated 3 samples and we only accept 2. So we accept -1 and 0.3, and we reject 1.2. And that is that question done. Thank you.